Well, today we're going to use a line graph to evaluate quadratic inequalities. And here's the procedure we're going to go through. We're going to get a 0 on one side of the inequality. Then we're going to factor. Then we're going to draw a number line and put hash marks at the zeros. Then we're going to determine the sign for each interval, shade the appropriate intervals, and state the solution. We have 3 problems to do. And these are corresponding symbols we'll use. Whenever we have a less than or greater than, we'll use parentheses for interval notation for graphing. We'll use an open circle at hash marks because the boundary, the bound, the 0 is not included in the solution. Whenever we have an equal sign associated with the inequality, such as less than or equal to or greater than or equal to, in interval notation we'll use brackets, and graphing we'll graph with a solid circle at the zeros because the 0 is, or the zeros can be included, will be included in the solutions. So take a minute, copy this procedure down, and we'll move on and do several, or we'll do these, resolve these inequalities. Well, for the first inequality, we already have 0 on the right side of the inequality, so the next task is to factor. And let's see, we have an x and an x and a 5 and a 2, and the 5 will get the negative, the 2 will get the positive. Yes, let's see, the product of these two is 2x, the product of these two is negative 5x, the difference is negative 3x. Okay, now we'll draw our number line, and the zeros occur at negative 2 and 5. Those are our hash marks. Now let's see, we have an equal sign associated with this inequality, so we'll put a solid dot, solid circle, at the zeros. Now we'll sign the intervals. Now we have 1, 2, 3 intervals. So if a point in an interval gives a sign, then every point in that interval will give the same sign. So we only have to check one point in each interval. Well, let's see. How about negative 10 is in this interval? If we replace x with negative 10, each x with negative 10, we'll have a negative times a negative, and the product of an even number of negatives is positive. Let's check a point in this interval. How about 0? Letting x take on the value of 0, we'll have 2 times negative 5, and that's negative. Notice we don't care what the actual product is, we just care what the sign is. Now let's pick a value in this interval. How about 10? And so letting x be 10, we'll have the product of 2 positives, which is positive. Now we're interested in, because it's less than or equal to 0, we're interested in the negative signs, the intervals associated with negative signs, and we'll shade just that interval. And so our solution in set builder notation is x such that negative 2 is less than or equal to x, which is less than or equal to 5. In interval notation, using brackets, our left endpoint is negative 2 and our right endpoint is 5. And we'll move on to the next inequality. Well, this inequality already has 0 on the right, so we do have to factor, so we can factor an x out of each term. And now we're ready for the number line. And let's see, hash marks. There's going to be a hash mark at what value of x takes x to 0? Well, 0 does. What value of x takes this factor to 0? 4 does. So there's our hash marks. And no equal sign associated with the inequalities, so at the hash marks or zeros we'll put open circles. Now it's time to shade each interval. And as we said, if one point in an interval yields a sign, then every point in that interval will yield the same sign. So let's let x be -10, which is in this interval here. And if that's the case, then we'll have the product of a negative times a negative, which is positive. Now, for this interval, let's choose the point 1. Letting 1, or x take on the value of 1, we'll have a positive times a negative, which is negative. And for this interval, let's let x take on the value of 10. And so we'll have the product of two positives, which is positive. Now, the inequality is greater than 0, so we have to shade the intervals associated with the positives. And now we're ready to state the solution. And in set builder notation, we have the set x such that x is less than 0 or x is greater than 4. In interval notation, we have, -infinity to 0, parenthesis, union with, parenthesis, 4 to infinity. And we're ready for the next one.